Okay, section 3.1, we're going to be discussing scatterplots and correlation at the beginning of this chapter. When we use scatterplots, we are measuring how strong the relationship is between two variables. Those variables are called the explanatory and the response variables. The explanatory variable is always your x variable, and then the response variable is always the y variable. Okay, when we think about this, this is not a cause and effect relationship. However, the explanatory variable can often help you predict what the response variable will be, but it doesn't necessarily cause the response variable. Okay, so for example, the weight of a car. Okay, if you were to slam on your brakes and then it would skid possibly so far, how heavy the car is could affect what the death rate is for that accident. We know that if you're on a larger vehicle like a semi-truck or a school bus, you tend to not get injured near as badly as when you're in a smaller, more lightweight car. Okay, so the explanatory variable helps explain or predict what the response variable is. Okay, we want to think of it like this, that the explanatory variable accounts for changes in the response variable, but please keep in mind, this is very important, it is not a cause and effect relationship. Okay, so here in this first example, we have Tim. He wants to know if there is a relationship between height and weight. Kelly wants to know if she can predict a student's weight from his or her height. It says for each student, identify the explanatory and response variables. Okay, so let's talk about Tim first. It says here he wanted to know if there's just a relationship between height and weight. And so we don't have a ton of information there. There really is no clear explanatory or response variable. Okay, the way that that's worded, it's not indicating whether one of those variables is helping predict the value of the other variable. Now, when we look at Kelly's inquiry here, it says she wants to know if she can predict a student's weight from his or her height. Okay, so for something like that, keep in mind again, the explanatory variable is what helps explain. It doesn't necessarily cause it, but it helps explain the response variable. So the explanatory variable in this example would be a student's height, and the response variable would be the student's weight. Okay, so someone's height doesn't cause their weight to be what it is, but it certainly contributes to it or helps predict what it may be. Okay. All right, so how do we decide if there is any type of relationship or association between, say, two categorical variables? This is something we studied back in chapter 1. We had things like two-way tables. We did conditional distributions. We would make like a side-by-side bar graph, or maybe one of those stacked kind of bar graphs, segmented bar graphs there. And we would look to see if there was an association or not between the two categorical variables. In this chapter, we are going to be focusing on trying to decide if there is any type of relationship between two numerical variables. So how we do this when both variables are quantitative is we need to display the relationship between two quantitative variables using what's called a scatter plot. Okay, and that relationship, when we're talking about quantitative variables, is known as a correlation. Okay, so we often use the word association when we're referring to the relationship between two categorical variables, and we use the term correlation to describe the relationship between two quantitative variables. Okay, so let's take a closer look at scatter plots. I think you're a little bit familiar with scatter plots from previous courses, Honors Algebra 2 here. Okay, it says that a scatter plot shows the relationship between two quantitative variables. Okay, we know that the way that this works is we have our x variable along the x-axis, the y variable along the y-axis. Again, very important with any graph that you make in AP statistics that you are always labeling your axis both with a scale and then also with the context. Okay, take note that your axes, and you can see how the y-axis on this particular example, it doesn't have to start at 0. Okay, it doesn't have to start at 0. You can scale it where it's starting at a different value there. Okay. Okay, so let's go ahead and take a look here. It says to see if there is a relationship between body weight and backpack weight, a scatter plot was made. Okay, so someone who's going hiking, they have a really big backpack. It's pretty heavy. We're seeing if there's any type of correlation between our X variable, which is the actual body weight of the person, and then how much they're able to carry as far as the weight of their pack. That's our Y variable. Okay, so I'm going to go ahead and label X by body weight, Y by backpack weight. And I have a little note here off to the side, a graphic, reminding you how to make a scatter plot on your graphing calculator. Okay, what you would do is you would enter your X values into list 1 and your Y values into list 2. You would then need to go to stat plot, I believe that's second y equals, and turn on plot number 1 and define it as being a scatter plot. Okay, also important that you have L1 across from X list and L2 across from Y list. Okay, we're not going to waste time trying to come up with a good window. We're going to let the calculator do that for us. So you're going to press the zoom button, option 9 for zoom stat, and it would display a scatter plot. This is the scatter plot here, and you can see over here as well, for this particular set of data. Okay, if you remember, when we are describing distributions, we use the acronym CUS for center, unusual values, shape, and spread to help us remember all the key points that we need to hit on when we're describing a distribution. And we also have an acronym here that we use in AP statistics for how to describe scatter plots. Okay, what you're doing anytime you look at a graph is you're looking for patterns and then striking departures from those patterns. Okay, and here is our acronym for describing scatter plots. There are 4 things you're looking for. The acronym spells out the word DUFs. Okay, the first thing you're going to want to look at is you're going to want to look at the direction of the points. In other words, the slope. Okay. So questions you're asking yourself is the overall pattern of the points increasing? Are they decreasing? Or does it feel like there's not really a pattern and there's random scatter? Okay, to illustrate this with the scatter plot that we see up here with body weight and pack weight, you can see this definitely feels like it would have a positive association. It's okay to use the word association when you're describing 2 quantitative variables here. Okay, so if the points are increasing from left to right, we're going to say that it is a positive association. Of course, if it's leaning the other direction, we would say negative association, and random scatter would be no association. So the D in DUFs is direction, which is slope. You always want to address that. Okay, this is in a different order here, but the F in DUFs is for form. Okay, and form has to do with if you can fit a curve to the overall pattern. Okay, really what we're most interested in is if the form is linear. Okay, so does it kind of feel like it's following a general trend? It's likely not going to be in a perfect straight line, but is it following kind of the pattern of a straight line? Or is there any noticeable curve or something else to it, which we're just going to call it nonlinear if we're seeing any type of curve to the shape of the graph there, okay? Also, another thing to mention here with form would be clustering. And when I say clustering, this is what I'm talking about. I'm going to draw an example here. Let's say that you have some points maybe here, okay? And then there is a little bit of a gap, and then maybe over here we have another cluster of points, okay? This is what I mean. It feels like these are in 2 separate clusters because there's a gap in between, okay? So D, direction, F, form. S is strength, okay? When we talk about the strength, now we're talking about how strong is that correlation or association, that relationship between the two variables. They could have no association, an extremely weak association, a weak association, moderately strong, strong, or very strong, okay? We'll talk about how to distinguish that, but I will just mention that the more your points are together in a straight line, the less scattered they are, the stronger your association or correlation would be, okay? The more widely scattered they would be, the less association or the weaker that association would be, okay? And then lastly here, the U in Duff's is for the unusual features, or what we would know as outliers, okay? This would just be if there's any points that lie outside of the pattern, okay? Same thing with the CUS acronym. We kind of attached BS at the end of it for be specific. We always want to make sure that we're weaving in context when we are describing a scatter plot, that we are mentioning, like, for example, things like the variables, body weight and the pack weight. Okay, so let's go ahead and look at a few examples here. I've got some scatter plots graphed for you here. Now, you'll notice the first scatter plot, I do not have defined what the X and Y variables are. So it's a big no-no here in AP Stats. So I'm not going to really be able to use any context because they haven't given me what that context is. Okay, so I have 3 blanks here. Okay, and it's for these first 3 things we want to hit, and then we only address an outlier if it is visible in the scatter plot, okay? So we're going to say the data suggest and it really doesn't matter the order that you list these things in, so I'm going to call this a strong association, because it really feels like these points are kind of nicely clustered together here in somewhat of a tighter line here. So I'm going to say this is a strong, and then when it comes to form, there is definitely a distinct linear pattern here. So I'm going to call this linear. That'll be me addressing the form. And then I have to give it a direction, and it feels like it is sloped negatively. So I'm going to call this a negative association. Okay, association just means relationship. Okay, so the data suggests a strong linear negative association. Here's where I would use context if I knew what X and Y were, but I don't, so I'm just saying between X and Y. Okay, moving on to a number 2. Okay, now number 2 here, we can see that there is a distinct curve to this. So I'm just going to choose, when I do the form, I'm going to choose the term nonlinear. Okay, I'm going to say the data suggest now I am going to choose the word strong here because it does feel like these points are very tightly clustered together in a form here. It is nonlinear, but they are tightly clustered together. So I'm going to call that a strong, but then it's going to be nonlinear. Okay, and this is going to be, when I have to pick the direction, it kind of feels like all of these points have a positive association, but then it feels like when I get over here on the higher end of the x-axis, then I'm talking about the values having a negative association. So I might say something like this. The data suggests a strong nonlinear, I'll say positive association. Oh, let's get rid of this word between, for lower values of X, and a negative association for higher values of X, okay? Because when I'm over here on the left side of the X-axis, or the left part over here, I've got a positive association, and then as I get to the higher X values, now I'm feeling like the association is more negative. Okay. All right, and this last one, wow, these are really tightly clustered together. I'm going to call this, instead of strong, I'm going to call this very strong. Okay. Clearly, it's not linear. I'm going to say the data suggest a very strong, non-linear, positive association between, this is our first one where we actually have some context provided on the axes here. You can see they mention year. And what is this? This is the U.S. population, okay? So I'm going to say between year and U.S. population, okay? That's me weaving in the context there, okay? All All right, let's look at one more page here, and then we will bring this to a close here for today. Interpreting scatterplots, okay? It says when you're interpreting, you're telling what the data suggests in context, okay, in real world terms. For example, the data suggests that the more hours a student studied for Mrs. McConnell's AP Stats test, the higher grade the student earns. There is a positive relationship between hours studied and grade earned. Okay, that's what we mean. When we say that there is a positive association, we are saying that as one variable increases, the other variable is also increasing. And that right there is doing a really nice job of putting things in real world terms. Okay, so let's go back to this scatter plot that is relating someone's body weight with their backpack weight. Okay, and let's see if we can fill in a description here of the scatter plot. Again, we're kind of working through the DUFS acronym and want to try to weave in context. And I kind of have a little bit of a framework here for us. We're just going to fill in the blanks, okay? So the data suggest I'm going to choose a word for strength, okay? I do notice that they're more tightly clustered here. It feels like they're spreading out a little bit over here. So I might just call this, the data suggest a moderately strong. Okay, I'm also going to call this positive because it does feel like as the X values get bigger, the Y values are also getting bigger. So we're going to call this a moderately strong, positive, and I'll go with linear. Okay, although, you could argue they're starting to develop a slight curve, possibly, just really due to maybe that one point right there. So we're going to call this linear relationship between, okay, here's our context, body, weight, and pack weight. Okay, whoops, I'm sorry. I should have just put body weight, okay, and pack weight, okay? And then here's me doing a really good job of kind of putting this in real world terms. As the body weight increases, okay, so we're talking about as we move this direction on the x-axis, the pack weight increases. Okay, I see that in my scatter plot that as I move farther to the right, the points are also rising up there. Okay. One possible outlier, this is the U in DUFS, is, okay, and of course we know that would be this person here, which I'm going to roughly estimate that might be 187 pound person. Okay. Okay. The 187 pound person is, I'm going to say, is carrying less weight for his size than other people, okay? I would have expected that this person that weighed this much would have been able to carry the most of all of the people in this, so I would have expected this to have been up here. That's why we're saying this is an outlier. He's kind of carrying less weight for what his size is, okay? All right, let's look at one last one here. It says, describe and interpret the scatter plot below. The y-axis refers to the school's average SAT math score, and the x-axis refers to the percentage of students at the school who take the ACT. So as more and more students at the school are taking the ACT, what is that doing to the average math score for the school? Okay. So this definitely, feels like there's kind of a curve here. So I'm going to be calling the form nonlinear. Okay. Although it is kind of clustered together somewhat in that shape. So I might give it a moderately strong. And we're going to be looking on the next video at specifically interpreting the R value and helping us with what the strength would be. But when you just have a scatter plot like this to look at, you just kind of, pick what you think this looks like in terms of strength. So I'm going to say the data suggests a moderately strong, it's definitely negative because it's going down as we move from left to right, non-linear relationship between, percent taking SAT. Oh, I put all that on the line. Okay, we could move some of that down here. And mean math score. Okay, now here's my real world explanation here. The more students who take the SAT, the lower the average math score. Okay, it feels like the points are going smaller as we move farther to the right. So it says there are two distinct, we're going to call this clusters. Okay, it does kind of feel like as you look at this, I've got a cluster here and I've got a cluster right there. I just went over top of that point and I want to be able to see that. Cluster here and a cluster there. So there are two distinct clusters. Also, kind of feels like maybe two possible outliers for each cluster, okay? And we could call this maybe one about at the 18%, when 18% of the student body has taken the test, and the other one we'll just say when 88% of the student body has taken the test. Okay, all right, that is a good place for us to stop. There should be some homework problems right here at the bottom on your notes page that you should be